students, welcome to our chemistry class. Our chapter name is acids, bases and salts. In the last two classes we are discussing this chapter. And our last topic was this, the reaction with the acids and the base with different things. That means the reaction with the acid and the base. And also the reaction with the acid and the metal, the reaction with the base and the non-metal. Like we discussed about the reaction between different types of substances with the acid and the base. That is the last topic we discussed. And now we are going to discuss the further topics in this chapter. Now, today's first topic is, what do all acids and bases have in common? This is our topic. That means we know for the acids it is having certain chemical properties, and in the similar way for the bases also it is having some similar properties or chemical properties. So now the question is, why all these acids are behaving similar, or why all these bases are behaving similar? That means what is the common thing is that for all the acids? For all acids, what is common there? Or we can ask, what is the common thing for all the bases? That is the thing we are going to check. What is the common thing for all the acids and for all the base? So, for that, I am just recalling one concept that we already explained, that when the acid is getting react with metal, what we get? The gas. We get certain gas when the the metal is getting react with the acid. That means on the surface of the metal you can see some sort of bubbles are there forming, and we already studied that bubbles are the presence of certain gas, and that gas is nothing but the hydrogen gas. And this is actually a general equation, plus we have another component. I am not focusing on that, only focusing in this hydrogen component. And here we can say that for all the acids, it is producing hydrogen gas. So we can say this hydrogen is one common component for acid. I am not concluding it here, I am just started this topic. So this hydrogen is one common factor or common component for this acid. Now the question is, we have number of compounds are there. We have different types of compounds, and many compounds include the hydrogen component is there. That means for making the compound, one of the atom is hydrogen. Many compounds. And now the question is, do the all compounds including hydrogen is acid? That is the question. We said that this hydrogen is one of the component is there in the acid. So the question, I am just reversing that, do all the compounds containing hydrogen is acid? That we want to check. First of all, we are going to check this by one experiment, and you can see the diagram in the figure 2.3. Now we are going to discuss that experiment. For this experiment, the setup is this. We are having one beaker, and at the bottom of the beaker I am just taking one rubber cork. And fixing it there. then just fix two metal nails. For example, you are free to take iron nails or anything. So our aim is this must be one conductor. So I am just selecting any of the metal, that is two nails, and then connecting metal wire to these two iron nails or these nails. And then we are doing that connecting battery to this, then bulb is there and we have key is there. So this is our circuit, and first of all we are not adding any type of solutions here, and when I close the key, what happens? Do this bulb is getting glow? No. What is the reason? Do our circuit is complete now? Not at all complete. The reason is very simple, that what is this? I already said that this is rubber cork. Do this rubber is a conductor? No. So actually our circuit is not at all complete. Here it is having one gap. You can see that. That means the electricity is not flowing through this circuit now. The reason is this circuit is not complete. So that's why the electricity is not flowing through this and the bulb is not at all glowing. Now we are going to do the experiment by adding certain type of liquids in this beaker. That is our experiment. For that I am selecting some sort of things that our aim is to check for all the compounds containing hydrogen is acid. We are going to check that. So I am selecting some of the compounds having the hydrogen. The first one is this C6H12O6. C6H12O6. This is the chemical formula for glucose. So in this you can see hydrogen is there. So this is one of the compound which is having hydrogen, and we want to check do this is acid or not. The next compound I am selecting is C2H5OH. C2H5OH. And what is this? This is alcohol. This is alcohol. And here you can see the hydrogen component is there. And one more thing you want to remember in this region is that this alcohol is actually a name for a particular type of group. That means it is a general name. And according to the length of the chain, we already discussed in the chapter carbon, that means according to the length of the chain, it is having different names for this alcohol. This alcohol is actually a general name, and I am also showing some other examples for this alcohol as C3H7OH, C4H9OH. These are also some examples for the alcohol. What is the difference here happens? This OH component is all there, but what is the difference is that the length of the carbon and the hydrogen change. This is the difference. So now here I am just selecting the C2H5OH, and the naming is now not there in your syllabus, so I am not explaining about the name and all. This is alcohol. And the third sample I am selecting is our HCl. HCl. We have the hydrogen component here, and that is what? Hydrochloric acid. Hydrochloric acid. And also we have one more thing, and that is H2SO4. H2SO4. And what is this H2SO4? It is sulfuric acid. Sulfuric acid. So here also we have the hydrogen component. Simply we can say that I am selecting 4 different samples of compounds that is having hydrogen. That is the simple thing. So selecting this glucose. That means I am just taking this glucose to this beaker and it is filling. Now we are observing, do this bulb is glowing. So in the case of glucose, the bulb is not glowing. Bulb is not glowing. Then I am repeating this experiment with alcohol. First we did with this. Secondly, we are selecting the alcohol and again repeating the experiment and observing, do this bulb is glowing. Not at all. Again, in this alcohol also the bulb is not glowing. Now we are repeating this experiment with this HCl, hydrochloric acid. And at this time when you observe this, you can see that this bulb is glowing. Bulb is glowing. That means in this case of hydrochloric acid, this circuit conducts means, what is the meaning here? This hydrochloric acid is having number of free ions. You already studied that if there is free ions present, then what happens? The electricity will flow. So, according to the hydrochloric acid, it is having free ions. Free ions present there, and because of that reason, this bulb is getting glow. And we are again repeating the experiment with the sulfuric acid, and at this time also you can see that this bulb is glowing. That means in the case of this glucose and this alcohol, the bulb is not glowing. Means what? In the case of glucose and in the case of alcohol, there is no free ions present. And because of this reason, this is not getting glow. That means when we are adding this glucose in this beaker, still the circuit is incomplete. And when the circuit is complete, then the electricity will flow. Why it is incomplete? Because it is having no free ions present in this. And when we are talking about the acid, these both of the things. Here we selected this hydrochloric acid and sulfuric acid. We simply selected two samples. So, when we are talking about this hydrochloric acid and sulfuric acid, what happens? They have free ions and that's why the bulb is getting glow. So, this is the thing about this experiment. I hope it is clear. And now the question is, this is acid we already said. What is this glucose and alcohol? Is it base? No, it is not base. And it is not acid. Actually, this glucose and alcohol is not acid nor base. So, for the acid we know there is having free ions. Again, I am repeating this experiment by selecting the base. That is, two samples are there. I am selecting the sodium hydroxide, NaOH. And repeating this experiment. Here I am selecting liquid sodium hydroxide. So, at that time also you can see that bulb is glowing. So, we can say for the base also there is having free ions present in this. And this is not base, no acid, and that's why there is having no free ions. So, we want to check what ions are present in alcohol and what type of ions are present in base. And one more thing you want to remember here, I already said that we are selecting the sodium hydroxide is liquid state. And if we are conducting this experiment by selecting the sodium hydroxide in solid state, the conduction will not occur. So, that means in the liquid state there is having free ions and so the electricity will flow. But when we are selecting the solid sodium hydroxide, then no electricity will flow through this. Just put it in your mind. So, now we are going to check what is the ions present in acid and what is the thing there in base. actually? Ion is the charged species. This you already studied in the 9th standard. So these ions are charged species, or we can say it as the atoms having charge, that is this ions. So we have 3 types of ions: positive ion, negative ion, and also polyatomic ion. Polyatomic ion, positive ion, negative ion, and polyatomic ion. Positive ion means the ion having positive charge. The negative ion means the ion having negative charge. And what is this polyatomic ion? Polyatomic ion is actually the ion which is having a single charge with more than one atom. I will show you the example later. We have to discuss. So now I am going to focus that this positive ion, what is the name of that? This positive ion, is it anion or cation? This positive ion is cation. And this negative ion is anion. Positive ion is cation and the negative ion is anion. And now I already said that we are going to check which type of ion is there present in our acid. So in the acid means all the acid, it contains cation. Cation means the positive ion. So for the acids, it is having cation. What cation? It is having H plus ion. H plus cation, we can say it like that. So for all the acids, it is having H plus ion present. And actually, because of the presence of this H plus ion, the acid is showing its acidic properties. We already know which are the acidic properties we discussed in our previous classes. So this H plus ion is the reason for all the properties that is for this acid. So we can say in the acid it is having H plus ion. And we said that for the alcohol and glucose, that is the C6, H12, O6, and for this the glucose, this is glucose, and for the alcohol it is the C2, H5OH, and the HCl. Now I am going to focus what is the difference. Actually, for this hydrochloric acid, it is having the ion H plus, and here it only have the hydrogen, not the H plus. That's why this is not conducting electricity and this is conducting electricity. And also H2SO4, it is also having the H plus ions are present there. And so this conducts electricity and the bulb is getting glow, and here it is not glowing because this alcohol and glucose do not have H plus ion. It only have what? This hydrogen is there, but you want to remember this hydrogen and the hydrogen ion is something different, not the same thing. So that's why this is not conducting electricity and this is conducting electricity. I hope it's clear. And also another example is there for the experiment that the sodium chloride, aqueous solution of sodium chloride also conduct electricity. Just read it, it's there in your textbook. So next there is one question that why the tap water conduct electricity but the distilled water do not. Why? That is a question. Why this tap water conduct electricity and why the distilled water do not? The reason is very simple, that this tap water, that means I am just taking two beakers. This is tap water, beaker A, and this is distilled water, beaker B. And so, when you observe this, you can see that in the tap water, the present number of salts. These salts are actually what? Ions, and because of this reason, they can conduct electricity. But this distilled water means it is the pure water. We are making the distilled water, or we are purifying the water and making it distilled water. That simply means that there is having no such salts dissolved in this water. It is very pure. That means no salts and there is having no ions. If there is no ions, no conduction will occur. So, in the tap water we have what? Ions present. What is these ions? It is having number of different types of salts are there. And so that's why it conducts electricity, and this is not conducting electricity. And the reason for the conduction and here not conducting, because of the ions. And you want to remember, if there is having free ions, if we have free ions, then it conduct. If no free ions, then do not conduct electricity. We are talking about electricity. So this is the answer for this question. I hope it's clear. Now we are going to discuss the next topic, and that is what happens to an acid or a base in water solution. What happens to an acid or base in water solution means what happens when we mix the acid with the water, and what happens when the base is getting mixed with water. That is the meaning of this. Simply means that what happens when this acid is getting mixed with water, what is the change occurs with the acid. That is the meaning of this question. For that, again we are conducting one experiment, and the setup is in the figure 2.4. Figure 2.4. The experimental setup is very simple, and that is this. Take one test tube. We are taking one test tube, and the speciality of this test tube is this is dry test tube. Dry test tube. That means there is no water content or the moisture is not there in our test tube. We are making the test tube dry. And after that, we are taking some solid NaCl in this. Solid NaCl, sodium chloride. We are selecting some solid sodium chloride in this. That means we are not selecting the liquid form or aqueous form. We are selecting the solid NaCl. Now we are going to add drop by drop concentrated sulfuric acid. Concentrated H2SO4. We are adding concentrated H2SO4 to the solid NaCl drop by drop. And when we are adding this drop by drop, you can see that in the test tube there is formed certain type of gas. Here form certain type of gas. Now our duty is to check what is this gas. And we don't want to escape this gas to outside. So I am just closing the mouth of this test tube with a cork. And when we are continuously closing this, what happens? This test tube will break. So I want to take this air outside. Just putting here one delivery tube. The delivery tube means a tube which is in a bending shape. This is what delivery tube. So I am just connecting this delivery tube to this cork, and now you can see that the formed gas can escape to outside through this tube. That means the gas will come outside. And actually, the gas which is formed here is HCl. HCl. Now the question is how I identified that is HCl. We are just going to write the equation for this experiment. That is, what is our reactants? Our reactant is NaCl and H2SO4. When this NaCl and H2SO4 is combined together, or means when they are reacting together to NaCl plus H2SO4 gives, that is, when the sodium chloride is getting reacted with sulfuric acid, then what is the product? We get the product as Na2SO4 plus HCl. So you can see the Na2SO4 is there left in the bottom of the test tube, and this HCl is actually the gas formed here. Gas. That is in gaseous form. That is the hydrogen chloride. And so what is this Na2SO4? What is the name of this? This is sodium sulfate. Sodium sulfate. For the sulfate, the spelling is FAT. So sodium sulfate is this Na2SO4. So when we write the equation, we get identified that this gas is hydrogen chloride, HCl. And so now the question is, we have to check the gas with the presence of litmus paper. That means, is it behaving as acid in the presence of litmus paper? That we are going to check. So just want to remember this equation that to NaCl plus H2SO4 is getting reacted, we get the product as Na2SO4 plus 2HCl. When it is coming the 2 here, then the equation will be balanced. So this is the equation. And this Na2SO4 is what? Sodium sulfate. And here this hydrochloric acid HCl is in the form of gaseous form. So we are continuing our experiment. Just put this equation in mind. And we understood that here forms the HCl gas. HCl gas. And in your textbook you can see another setup is attached that the guard tube. Now we are going to explain what is this guard tube. In some cases, the atmosphere is full of moisture and water content. And our aim is to get this HCl gas without any water content. That is our first aim. For that, when the atmosphere is full of moisture, what happens? This HCl suddenly getting react with the moisture present in our atmosphere. Moisture means the water content. So, when this HCl is getting react with this water content, then the behavior of this HCl gas will change. So, when our atmosphere is moistured, then we are using that. And I am not telling that we will do this for every experiment like this. No, when our atmosphere is filled with moisture, we are using this for better result. So, that setup is this. We are just connecting that guard tube here. Guard tube is a simple setup that is having inside this the calcium chloride filled. Calcium chloride crystals are filled in this tube. And the name of this tube is this. Guard tube. Or it is also called dry tube. That is, the working of this tube is what? To dry the gas. If this gas is having any content of water, we are just moving this air through these crystals, and what happens? These crystals will absorb the water content and the outside will come dry HCl gas. So for that we are just connecting, and we are only using this if our atmosphere is moistured, and if there is no moisture, no problem. We are directly taking this dry HCl gas. And the name is this guad tube, and also in this, what is the calcium chloride. Calcium chloride is filled in this guad tube, and the application of this is to absorb the water content in this gas. I hope it's clear. Now we are again back to our experiment. I already said that we want to check this gas with the litmus paper. With the litmus paper. So now here we get the gas, and I'm just selecting 2 litmus papers, and both are in blue color. Both are in blue color. But the difference is this: one is dry and other is wet. That means we are just dipping this blue litmus paper in water. That is this wet. And dry means having no water content there. So first we are checking this HCl gas with this dry litmus paper, and this is blue. And when you observe this, you can see that there is no color change will occurs with this blue litmus paper with the dry and for this HCl gas. That is, once more repeating, for this dry litmus paper there is no color change occurs. That means there is no such reactions or taking place, and we can say that here this HCl is not at all behaving like acid. This HCl is not behaving as acid. Why I said it like that? The reason is this: we already studied for the litmus paper A, B, R. If it is acid, the blue litmus paper will turn into red. If it is acid, the blue litmus paper turns into red. And here you can see there is no color change. That means we can say what? The no acid behavior is showing. Now we are repeating the same experiment with the wet blue litmus paper. And here you can see that the blue litmus paper is turned to red. So we can say that here this is behaving, this HCl gas is behaving as acid. So we can say that with the presence of water, the ions, we already said that the acid is getting its old properties with the presence of the H plus ions. And so we can say that with the presence of water, it forms H plus ions. It forms H plus ions. And if there is no water present, then it is unable to produce this hydrogen plus this H plus ions, and so it is not behaving as acid. We already said that for the acid it is having H plus ions. It wants the H plus ions, and if there is no water content, then there is no H plus ions will form. This is the altogether output of the experiment. What is that? Our aim is to check what is the role of the water within the behavior of acid. So we can say it as when there is having water content, then this HCl is able to produce H plus ions. Otherwise this HCl is only a compound not behaving as acid, and then this water is getting react with this HCl and form H plus ions, and how we can say it as acid. So we can say the equation of this. I hope this experiment is clear, and a neat diagram is there in your textbook, and please observe that diagram in the page number 23, figure 2.4. So we can write the reaction of HCl gas with the water as HCl plus H2O. This is the water and this is the hydrochloric acid or HCl that is having the gaseous form. So when it is reacted, the product is this H3O plus Cl minus. In all these areas, I said that we have H plus ion like that. Now what is this we got? H3O plus. What is this? Don't think that this plus is only for the oxygen. Actually, this H3O plus is what? A single component, or it is actually a single ion. And I already said that we have polyatomic ion. Polyatomic ion means a type of ion that contains more than one atom. Here you can see, here 3 hydrogen is there and 1 oxygen, and this together a group, and for this H3O, one single charge is there and that is this plus. So when this HCl is getting reacted with water, you get this H3O plus, and that is what the behavior of acid. This H plus ion is similar to this H3O plus, and plus this Cl minus is with the reaction with the HCl. So we can say when there is having the ions present, this H plus ion, or we can say this H3O plus ion present there, then it acts as acid. Or if it is not having water, if it is not reacting with water, what happens? There is no such ions will present and it will not act as acid. And now the question is, what is the name of this H3O plus? And also, now there is one question, why we are not having this H plus in this reaction? The reason is very simple. The outermost shell of the hydrogen, the atomic number and all for this hydrogen is what? The 1. And because of this reason, this hydrogen is always showing certain exceptional properties. And one is this. The reason is this, that this hydrogen is unable to stand alone. So that's why this hydrogen is combining with water and form this H3O plus. That is the reason for that. That is, this hydrogen H plus ion cannot exist alone and combine with the H2O molecule, and that's why therefore H3O plus ion. And here we just selected it as HCl and the water. And now we are going to write, just avoiding this HCl and just selecting it as the H plus ion. We said that when this H plus ion, I already said that it is unable to stand alone. So when this H plus ion is getting react with H2O, that is our water. And what is the product? Very simple. Already said that is H3O plus. This is what we get in our last equation, H3O plus. And this is one polyatomic ion. And this plus charge is for all the things. And this is about this. And we said that all about the acid. Now, what about this base? Is it same H plus ion is there in the base? Now we are going to check that. For that we want to write the equations for that, and that is, now we are going to check about base. And the equation is this for the NaOH. What is this NaOH? Sodium hydroxide. For the sodium hydroxide, when we are adding water, that is when we are adding H2O, what happens? What is the product we get? We get the product as Na plus, that is in aqueous form, plus OH minus that is also in aqueous form. Here this NaOH is what? In solid state. So solid sodium hydroxide is mixed with water, then we can get it as Na plus OH minus. This OH minus means we will tell later. And now we are going to check the next one with the reaction of potassium hydroxide, KOH. Potassium hydroxide. Potassium hydroxide. So this is also in solid state and getting reacted with H2O. That means we are mixing it with water. What is the product we get? We get the product as K plus. That is the positive ion of potassium. That is in aqueous state plus OH minus. That is also in aqueous form. This is the products we get when the potassium hydroxide is mixed with water. And also we are checking another reaction, that is the magnesium hydroxide, MgOH twice. That we are using this base and acid, all the things with these equations. That's why I said in the first class that you want to study the names of this and the chemical formula also. MgOH twice is what? Magnesium hydroxide. Magnesium hydroxide. Magnesium hydroxide is MgOH twice. And when this is getting reacted with H2O, that means when we are mixing this with water, what is the products we get? We get the product as Mg2 plus. Mg2 plus, and that is in aqueous form plus 2OH minus, that is in aqueous form. So these are some of the samples we selected. Sodium hydroxide is there, potassium hydroxide is there, magnesium hydroxide is there. We are just selecting some of the samples and we are mixing these with water. And when we are mixing this with water, we get certain products. And you can see a common factor in these three equations, and that common factor is this OH minus. Here also the OH minus. Here we have two, that means the two molecules, and still here we have OH minus. So we can say that for the base, it is having the component OH minus, and for the acid it is H plus ion. This OH is what? OH minus is also ion, and that is the present in the base. And for the acid it is H plus ion, and for the base it is OH minus. And we call this OH minus is hydroxide ion. Hydroxide ion. So nothing is just we are writing the equations with the sodium hydroxide, potassium hydroxide and magnesium hydroxide with the reaction with the water. We get a common component available, that is OH minus. That is the only thing we are focusing in this region. So we can conclude this as acid, we said that it is having H plus ion, but because of its problem having it is unable to stand still, we want to write it as H plus aqueous, or we can write it as H3O plus. Both are same. H plus aqueous means this H plus is getting reacted with water. That is what this H plus aqueous. This H plus aqueous and H3O plus both are same. And what is the name of this? The name of this is hydronium ion. Hydronium. Hydronium ion. That is what the present in the acid and showing the property of acid. And what is there in the base? That is OH minus. the OH minus is there present in the base, and that is what? The name of this is hydroxide OH minus ion. So that is the name of this. H plus aqueous or H3O plus is what? Hydronium ion, and this OH minus is hydroxide OH ion. This is there in acid and this is there in base. So that is the simple thing just mentioned here. And now we are going to study the equation, that is the how the acid and base is getting reacted. We already know the equation. When acid is getting react with the base, what is the product we get? We get the product as salt plus water. We already studied this equation, this general equation, that when the acid is getting react with base, we get it as salt and water. And here now I am going to write this with the representation of H plus and OH minus. So for this acid, that I am writing it as H plus X. This X is one variable. And also I am not representing this plus here. That is silently meaning that. And plus, what about the base? It is having OH minus. And I am writing one variable here, and that is M. MOH means a particular base, and this HX means what? Acid. So this H is having plus sign and this OH is having minus sign, and we are not representing that in this equation. And so this X is a variable and this M is a variable, and what is the product we get? You can see here this X and M are two variables that are combining together, and we get it as XM plus, what is the further thing? What is the remaining thing here? HOH. That is, we are writing it as HOH. So you can say this salt XM is what? The salt. And this HOH is, we can rewrite it as H2O. And what is that? That H2O is water. This is water. So that means when this H plus, that means the acid and base is getting reacted, this OH is minus, they produce salt and water. And which is this salt? XM. And which is the water? This HOH, that combined together we can write it as H2O. So we can write it as, when this H plus, that is in aqueous form, is getting react with this OH minus, that is also in aqueous form, we get the product as H2O. That is the water, and that is in the liquid state or liquid form. So when the H plus ion and the OH minus simply means that the acid and base, the reaction, the same equation is this, but here we are notating it with the positive ion and the negative ion, H plus, aqueous and OH minus. So when they are getting react together, we get the product as water. That is the meaning of this equation, and you can see it in the textbook. So nothing is there, just remember this H plus aqueous is the component of acid, and this OH minus aqueous is the component of base. And now the thing is, what happens when the acid is getting react with, what happens when the acid is getting react with water, and what happens when the base is getting react with water? So I am just taking two test tubes and taking water in both of the test tubes. Here we have water, here also we have water. I am just selecting this in this test tube, and then I am adding the acid drop by drop. And here we are adding the acid concentrated H2SO4, concentrated sulfuric acid. And generally we are conducting the experiments that we discussed in our last classes are actually what? Diluted sulfuric acid. What is the difference between this concentrated sulfuric acid and dilute sulfuric acid? The difference is very simple. The strength is different. That means for the concentrated sulfuric acid, the strength is higher, and for this, or the power for this acid is higher in the concentrated, and the dilute means the power is less. Here we are adding the concentrated sulfuric acid in the water, and how we are adding this? Not we are adding a huge amount of acid to this water. When we do like that, what happens? The occurs splash out. That means this beaker or this test tube will break. So we want to add this concentrated sulfuric acid drop by shaking continuously. That is how we want to add this. And in the second test tube, we are adding drop by drop the NaOH, that is the sodium hydroxide. So we are taking two test tubes, taking water and adding concentrated sulfuric acid in this and the sodium hydroxide in this. So within the experiment, when we touch the bottom of the test tube, you feel the heat energy. Here also you feel heat energy. And I already said that when we add too much of acid in this, it will splash. How this is getting splashed out? What is the reason? For the breaking, for the explosion, there needs certain type of energy. And what type of energy is this? The energy is nothing but the heat energy. So we can say the high amount of heat energy produced will cause this explosion. So for reducing the production of heat energy, we are continuously adding small amount of acid and shaking it continuously. So here you just want to remember, when the water and acid is getting reacted, what produced the heat is produced there, and we can call it as exothermic reaction. This is the exothermic reaction, and this is also another exothermic reaction. Which is exothermic reaction? When the acid is getting reacted with water, then it is exothermic. And when the base is getting reacted with water, it is also exothermic reaction. So just put it in your mind. And here, why we are doing this experiment? And one thing you want to remember, we are selecting large amount of water and we are selecting some drops of concentrated sulfuric acid. That means the content of acid is less and the content of water is higher. Here also the base is in very less quantity and the water is in higher quantity. So actually our aim is to reduce the concentration. Reduce the concentration, and so we call such process is called dilution. So what is this dilution? Dilution means we are reducing the concentration of certain acid or base. So we can generally say it as it is the process of decreasing the concentration of solute in solution. That means we can say it as within a test tube we are selecting here water and we are giving drops of acid. So this acid is what? Solute here. Within a solution which is there in lesser quantity, and that is what? Solute. And here where this solute is dissolving water, and that is what? Solvent. So we can say it as when this acid drops. So this acid is getting mixed with water. What happens there? There happens the dilution. So the simple definition is this. It is the process of decreasing decreasing the concentration of a solute in a solution. So it is the process of decreasing the concentration of a solute in solution. Here solution means the mixture of this acid and the water. And also here we have solute. Solute means what? The acid. So this dilution means it is the process of decreasing the concentration. Simply we can say that it is the process we are decreasing the amount of acid here and we are mixing it with water and we are making a very diluted acid. We can say the acid is diluted. We are decreasing the strength of this acid. What is the happens like that? So this is all about this. And in between the topic we discussed about the topic alkalis. What is this alkalis? Generally we are talking always this acid and alkali together in the similar way as we are talking about the acid and base. Now my question is, do this base and alkali are same? Have any difference between these two? That is the question. The thing is very simple actually. This alkali and the base are not the same. They are not the same. But it is something related to base. For example, when the base is dissolved, the base is dissolved in water. When the base is dissolved in water, we can say it as alkali. So there are some other bases which are insoluble in water. This dissolved means it is soluble in water. And we have another type of base which is not at all dissolved in water. That means it is insoluble in water and that is not alkali. So we can say this alkali is the base which dissolves in water or which soluble in water. And the base which is not soluble in water, that means the base which is insoluble in water is what? Not alkali. That is the difference between this alkali and the base. So you want to remember the examples for this alkali and also remember the example which is not at all alkali. So the examples are these: NaOH, CaOH twice. NaOH means what? Sodium hydroxide. And this CaOH twice is what? Calcium hydroxide. The next one is potassium hydroxide, KOH. And the next one is this MgOH twice, that is the magnesium hydroxide. And also NH4OH. This is what? Ammonium hydroxide. These are the names we already studied in the first class of this chapter. And so these all are the examples of alkali. That means these all are soluble in water. And now we want to study one example that which is not dissolved in this water, and that is what? Barium carbonate. Barium carbonate is one base but which is insoluble in water, and so we can say it is not alkali. Very simple thing. So I hope it's clear. In this area you want to study what is alkali. Alkali is the base which is soluble in water, that is called alkali. Then you want to remember the names of this alkali or the examples of alkali. Just remember this. And also remember which is not alkali but this is base. So we can say this is insoluble in water. This is insoluble in water but it is soluble in acid. Soluble in acid. So just remember the names of this. And this area is this. In the first class, we studied about the indicators. What is this indicator? We use indicator to identify a substance is acidic or basic. So, for example, I am just taking two test tubes. Here, this is filled, both are filled with, this is concentrated H2SO4. This is full of concentrated sulfuric acid, and this is dilute sulfuric acid, H2SO4. And we have some indicators like litmus paper, turmeric indicator, like the natural indicators and the litmus paper like that. And using that, you can identify this is acid. But the problem is this, it is unable to identify is it concentrated or dilute. You can identify with the looking the color, I am not focusing that. But using that litmus paper or the turmeric indicator, it is unable to identify is it concentrated or dilute. That means it is unable to identify the power of the acid or the strength of the acid. It is not able to identify. That means the how much strong this acid is. That is not at all identify using the normal indicators. So for that, we are deriving another type of indicator, and that is the universal indicator. Universal indicator. What is this universal indicator? Actually, this universal indicator helps us to identify how much strong this acid is, or how much strong this base is, that we can identify using this universal indicator. This universal indicator is actually the mixture of, it is the mixture of several indicators. Several indicators, and this show different color for different concentrations. And this universal indicator is actually the pH scale, and we will discuss this pH scale in our next class. So in today's topic, we basically discussed about what the component is there within the acid and within the base that is having the property for this. That means within the acid it have H plus ion, and for the base it is having OH minus ion, and this ion is the reason for the acidic property and for the basic property. That is the only thing we discussed today, and you want to study the experimental setup and all. For that we already explained, and want to read your textbook, and we will meet in our next class with the universal indicator. Thank you.